Okay, so let me summarize our discussion so far. We have been computing the cross section for Compton scattering. So, E minus plus gamma going to E minus plus gamma, and then we have seen that the differential scattering cross section d sigma is given by alpha square over 2 sum over r s mod m over minus I e square whole square k0 prime over k0 square d omega, where this quantity here m over minus I a square we have seen is given by u bar r p prime epsilon prime slash 1 over p slash plus k slash minus m epsilon slash plus epsilon slash 1 over p slash minus k prime slash minus m epsilon prime slash us p, which is of this form u bar r p prime times some operator us p. What we are interested is mod square of this summed over r s. So, I will denote this quantity x to be sum over r s mod u bar r p prime o u s p square, and what we have seen is that this quantity is nothing but it is given by trace of o p slash plus m over 2m o bar p prime slash plus m divided by 2m, where o is given by this quantity here. So, when I substitute this for o, and our o bar is gamma 0 o dagger gamma 0. When we substitute for o, what we get is this quantity is nothing but a sum of 4 terms. So, let me do one more step. This is trace of epsilon prime slash epsilon slash k slash divided by twice p dot k plus epsilon slash epsilon prime slash k prime slash over twice p dot k prime, this times p slash plus m over 2m k slash epsilon prime slash over twice p dot k plus k prime slash epsilon slash divided by twice p dot k prime p prime slash plus m divided by 2m. So, this is the quantity. This I have expressed it in terms of T1, T2, T3, T4. So, x is equal to, if I expand this, I will get 4 terms. So, I have denoted them as 1 over 16 m square p dot k square T1 plus 1 over 16 m square p dot k prime times T2 plus T3 plus 1 over 16 p dot k prime square m square T4. We have evaluated T1, and then we have shown that T1 is equal to trace of epsilon prime epsilon slash k slash p slash plus m k slash epsilon prime slash p prime slash plus m. We have evaluated the trace and then we have shown that this quantity is given by 8 p dot k times 2 epsilon prime dot k square plus p dot k prime. We are going to evaluate T2, T3 and T4, but you can notice that if you just look at the expression for T4, then this is given by first and last term. So, this is a trace of this is the last two terms multiplied in between these two. So, epsilon slash epsilon prime slash k prime slash then p slash plus m k prime slash epsilon prime slash epsilon slash p prime slash plus m. Now, you can notice one interesting fact. This T1 and T4, they are related to each other by this. If you exchange epsilon to epsilon prime and if you exchange k to minus k prime, then this term and this term are the same. Okay? So, you do not need to evaluate this T4 explicitly. All you have to do is you have to do this substitution in T1, then you will get what you want for T4. So this immediately tells us what T4 is. It is simply 8 p dot k prime with a minus sign and then twice epsilon prime dot k prime square plus minus p dot k. Sorry, epsilon dot. So, epsilon prime goes to epsilon, k goes to minus k prime, but there is a whole square. So, this is twice epsilon dot k prime and here k prime goes to minus k. So, therefore, I got a minus sign. There is an overall minus sign because of the presence of p dot k. So, immediately I evaluated T4. Similarly, you can see that T2 and T3 are also related by the same symmetry. If you consider exchange of the photon polarization and the momentum with a minus sign, k goes to minus k prime, then T2 is related to T3. So, it is enough for us to compute T2, which is given by T2 equal to trace epsilon prime slash epsilon slash k slash p slash plus m k slash epsilon prime slash epsilon slash p prime slash plus m. So, T2 is the product of this and T3 is the product of this. Okay. So, these are T2s and T3s and you can see clearly that T2 and T3 are related by this symmetry that I have given here. So, we will work out this trace in detail and then from T2 we will get the expression for T3 also. Finally, we will put all these values for T1, T2, T3, T4 in this expression, and we will put x in the expression for the differential scattering cross section. Finally, we will get the differential scattering cross sections. So, let's try to do this trace. You start with this, and then you note that P prime plus K prime is equal to P plus K, the energy momentum conservation rule. So, P prime is just P plus K minus K prime, which I will substitute here. So, when I do that, I get trace epsilon prime slash epsilon slash K slash P slash plus M and K prime slash epsilon prime slash epsilon slash. This quantity is just P slash plus M plus K minus K prime slash. All right. So, the trace of this thing. Now, what I will do is that I will take this, I will use the cyclic property of trace, and then I will bring this pair here, and then I will split it into two terms. In one I will just have P slash plus M, and in the other I will have K slash minus K prime slash. So, let us do that. So, when I do that, I get trace of K slash P slash plus M K prime slash epsilon prime slash epsilon slash, and then P slash plus M epsilon prime slash epsilon slash. That is the first term, and the second term is a trace of K slash P slash plus M K prime slash epsilon prime slash epsilon slash, then K slash minus K prime slash epsilon prime slash epsilon slash. That is the second term. We will evaluate each of these terms. So, let us consider the first term first. Okay. So, the first term, again you can see in general, if you expand this, you will get 4 terms. Okay. One which does not contain M at all, the other one contains M square, and there are 2 more terms which are linear in M, but the terms which are linear in M contains odd number of gamma matrices. You can just count 1, 2, 3, 4, 5, 6, 7, 8. So, they contain 7, 1 P slash will go away. So, they contain 7 gamma matrices, trace of that is 0. So, therefore, the first term is simply trace of K slash P slash K prime slash epsilon prime slash epsilon slash P slash epsilon prime slash epsilon slash. This is the first one, and then the second one contains M square trace K slash K prime slash epsilon prime slash epsilon slash K prime slash epsilon prime slash epsilon slash, and again epsilon prime slash epsilon slash. Okay. Now, what we can do is you can bring this this P slash to this end here, okay, because P dot epsilon equal to P dot epsilon prime equal to 0. This implies P slash epsilon prime slash is minus epsilon prime slash P slash So, if you move it once you will get 1 minus sign. Similarly, again p slash epsilon slash is minus epsilon slash p slash. So, you will get 2 minus signs which is plus 1. Therefore, what you can do is you can just pull this p slash to here, and then you can use the cyclic property of trace, and then finally this p slash you can write it here. So, therefore, this becomes trace of p slash k slash p slash k prime slash epsilon prime slash epsilon slash epsilon prime slash epsilon slash. This is the first term, and the second term is m square trace of k slash k prime slash epsilon prime slash epsilon slash epsilon prime slash epsilon slash. But now you notice this term here, okay, these 3 terms, the first 3 terms, it is p slash k slash p slash, which is given by p slash k slash is minus twice, sorry, plus twice p dot k minus k slash p slash, right, this times p slash. Therefore, the first term you get is twice p dot k p slash, and in the second term you have 2 p slash. What is p slash square? It is simply p square, which is equal to m square. So, this is minus m square k slash. Now, in the second term, if you just see minus m square k slash here, this will exactly cancel with this term here. Okay. So, this term here cancels this, and hence this is simply given by twice p dot k times trace of p slash k prime slash epsilon prime slash epsilon slash epsilon prime slash epsilon slash. So, the whole thing here now reduced to some trace which involves 6 gamma matrices. We can further simplify it, and then we can write it in terms of the product of all these p's, k's and epsilons. So, let us do that. So, we are evaluating the first term, and we have seen that this reduced to twice p dot k trace of p slash k prime slash epsilon prime slash epsilon slash epsilon prime slash epsilon slash. Okay. Now, I can again, what I can do is let us see what is the simplest thing. Good. So I can bring it here, okay, and then I will use the fact that p dot epsilon equal to 0, then if I pull it here, it will get 4 times minus 1, which is again plus 1. So, this quantity itself is equal to twice p dot k trace of k prime slash p slash epsilon prime slash epsilon slash epsilon prime slash epsilon slash. Is this clear? first I use the cyclic property of trace, so that I take this p slash here, and then I use this property p slash epsilon slash p slash is minus p slash epsilon slash, and epsilon prime slash p slash equal to minus p slash epsilon prime slash. So, I use each of these twice, then I get this identity. Okay. Now, what I can do is, so this quantity is twice p dot k times half of sum of these two terms, okay, half of trace p slash k prime slash plus k prime slash p slash times epsilon prime slash epsilon slash epsilon prime slash epsilon slash. Now, what is this quantity? A slash b slash plus b slash a slash is simply twice a dot b, because this will give gamma mu gamma nu gamma nu gamma mu, which is twice eta mu nu times a mu a nu, which is twice a dot b. So, therefore, what I get is twice p dot k times half times 2 will give me 1 p dot k prime trace of epsilon prime slash epsilon slash epsilon prime slash epsilon slash. All right. Now, I need to evaluate the trace of this, but anything which contains 4 gamma matrices, it is very easy to evaluate the trace. Okay. So, what I will show now is, I will show that trace of gamma mu, gamma nu, gamma rho, gamma sigma is equal to 4 eta mu nu eta rho sigma minus 4 eta mu rho eta nu sigma plus 4 eta mu sigma eta mu rho. So, then it is very easy to use this relation to evaluate this trace. So, let us now prove that the trace of 4 gamma matrices is equal to this, and then we will use this relation to evaluate this trace. It is very easy to prove this. You just have to pull this gamma sigma here 3 times and then use the cyclic property of trace. So, let us just see that trace of gamma mu, gamma nu, gamma rho, gamma sigma is equal to trace gamma mu, gamma nu times twice eta rho sigma minus gamma sigma gamma rho. All right. So, this is twice eta rho sigma trace gamma mu gamma nu, and then minus trace of gamma mu gamma nu gamma sigma gamma rho. Again, I will pull this gamma sigma here, then I will get this to be twice eta. By the way, trace of gamma mu gamma nu is 4 times eta mu nu. So, what I get is 8 eta mu nu eta rho sigma, and when I pull it once, I will get twice eta nu sigma times trace gamma mu gamma rho, which is minus 8 eta mu rho eta nu sigma, and then plus trace of gamma mu gamma sigma gamma nu gamma rho. All right. Now, in this expression again I will pull it once, then what I get is 8 eta mu nu eta rho sigma minus 8 eta mu rho eta nu sigma plus this will give you twice eta mu sigma times trace of gamma nu gamma rho, which is 8 eta mu sigma eta nu rho minus trace gamma sigma gamma mu gamma nu gamma rho. But this quantity is same as this. So, if you bring it here, this will give twice trace of eta, trace of gamma mu gamma nu gamma rho gamma sigma is equal to 8 times this quantity. Therefore, the trace of 4 gamma matrices is given by this. Okay. Okay, so now that we have proved this relation, I can use this to derive this trace. This will simply be given by twice p dot k prime times 4, the first term mu nu rho sigma will give you epsilon dot epsilon prime whole square, then you have minus eta mu rho nu sigma. We will say that first one will have dot product with the third one, second one will have with fourth one. So, minus 4 epsilon dot epsilon epsilon prime dot epsilon prime, and finally the last term will say that it is again epsilon prime dot epsilon whole square. So, plus 4 epsilon prime dot epsilon whole square. What is this quantity here? This is 1, because epsilon dot epsilon is minus 1. So, therefore, this term here is evaluated as 8 p dot k prime times twice epsilon dot epsilon prime whole square minus 1. All right. So, now that we have evaluated the first term, so this T2 has two terms. The first term we have evaluated, and then we have shown that this is equal to this. Now, we will come back to the second term here, and then we will evaluate this in more detail. So, let us summarize what we got here. We got the first term to be equal to 8 p dot k prime twice epsilon dot epsilon prime whole square minus 1. Now, we need to evaluate the second term. So, let us look at the second term. It is trace k slash p slash plus m k prime slash epsilon prime slash epsilon slash k slash minus k prime slash epsilon prime slash epsilon slash. Okay. Again, you see this involves, there are two terms, one with p slash here contains 8 gamma matrices, but the one with m contains 7 gamma matrices. So, the term which is linear in m will simply vanish. Therefore, this is trace k slash p slash k prime slash epsilon prime slash epsilon slash k slash minus k prime slash epsilon prime slash epsilon slash. Okay. So, now I will focus on the last three terms here. What I will get is, so let us do this, it is k slash minus k prime slash times epsilon prime slash epsilon slash. Okay. Now, you try to move this epsilon slash to the epsilon prime slash to this side. Okay. Then what you will get, the first term will have twice k dot epsilon prime minus epsilon prime slash k slash, and here k prime slash epsilon prime slash is simply epsilon prime slash k prime slash with a minus sign. So, this is epsilon prime slash k prime slash, the whole thing multiplied by epsilon slash, okay, because k prime dot epsilon prime equal to 0, we are considering transverse photons, therefore, k prime slash epsilon prime slash is minus epsilon prime slash k prime slash. Okay, so, now this has to be inserted here. Let us see what you get when you insert this. So, k slash p slash k prime epsilon prime then this is twice k dot epsilon prime epsilon slash, this is the first term, and then you have trace of the minus trace of k slash p slash k prime slash epsilon prime slash epsilon slash epsilon prime slash k slash epsilon slash, and finally trace of k slash p slash k prime slash epsilon prime slash epsilon slash epsilon prime slash k prime slash epsilon slash. All right. Now, you just look at the second term here. In the second term, I can flip k and epsilon using this fact that k slash epsilon slash is minus epsilon slash k slash. Then there is a k slash here at one end, but there is a k slash here. You use the cyclic property of trace, you bring this k slash here, that will give you k slash square, which is 0. So, the second term here vanishes because of this. Now, we are left with first and last term. Epsilon prime slash k prime slash so this is twice k dot epsilon prime trace of k slash p slash k prime slash epsilon prime slash epsilon slash epsilon slash. Okay. This is one term, and in the second term I have plus trace of k slash p slash k prime slash epsilon prime slash epsilon slash epsilon prime slash okay. So, let us look at this term. Here there are two epsilon slash. So, therefore, this gives you a minus 1. So, this term here is minus twice k dot epsilon prime trace of k slash p slash k prime slash epsilon prime slash, and then you have this term here which I have to simplify. Here this involves trace of 4 gamma matrices. So, I know how to do that. Here also what I can do is I can just rearrange things, so that this again reduces to something which involves trace of 4 gamma matrices, and then I can evaluate that in a straightforward manner. So, epsilon dot k prime so let's so I will focus this term here, okay, and then I will flip this k prime epsilon prime, I will get a minus sign. So, minus trace of k slash p slash k prime slash epsilon prime slash epsilon slash, and then this is k prime slash epsilon prime slash epsilon slash. This is 1. Then what I will do is that I will again take this k prime to this side, that will give me two terms. One of them will be simply so minus k prime slash epsilon slash plus twice epsilon dot k prime. That is what I will get from here. Okay. Now, you can see the first term which contains minus k prime slash epsilon prime slash, it comes with k prime epsilon prime here. So, what you get here for the first term is something which involves k prime slash epsilon prime slash k prime slash. What is this quantity? This is 0, because this again you can flip it, then you get k slash prime square, which is k square, which is 0. So, therefore, this term is simply 0. So, what you get is minus twice k dot epsilon prime trace of k slash p slash k prime slash epsilon prime slash, and here you have minus twice epsilon dot k prime times trace of k slash p slash k prime slash epsilon prime slash, and here again epsilon prime slash epsilon slash. All right, because for this I simply substituted twice epsilon dot k prime. Now, you have again epsilon slash epsilon prime slash square, which will give you 1 minus sign. So, this quantity here is plus epsilon slash. Okay. 2 epsilon dot k prime k slash p slash k prime slash epsilon slash. Okay, good. So, we have we have started with this term, and then we have reduced it to sum of two terms which involves trace of 4 gamma matrices. Therefore, we can easily compute them. Let us just write the answer for that, minus twice k dot epsilon prime times 4 times this is k dot p k prime dot epsilon prime minus k dot k prime p dot epsilon prime plus k dot epsilon prime p dot k prime. That is for the first term, and then similarly for the second term I have twice epsilon dot k prime times 4 k dot epsilon k dot p k prime dot epsilon minus k dot k prime p dot epsilon plus k dot epsilon p dot k prime. Okay. But now you use the fact that the photon polarization is transverse, and then we are working in the laboratory frame, so that it is again orthogonal to p. So, p dot epsilon and p dot epsilon prime are 0. Therefore, this term here is 0 because p dot epsilon prime is 0, and here because the photon polarization is transverse, k prime dot epsilon prime is 0. Now, here similarly this term survives, but p dot epsilon is 0 and k dot epsilon is again 0 because the photon polarization is transverse. So, now I will put all these things together, then what I get is minus twice k dot epsilon prime, there is a factor of 4. So, 8 k dot epsilon prime times k dot epsilon prime square p dot k prime, and the second term is again plus 8 epsilon dot k prime square p dot k. So, this is what we got for the second term. So, the first term is this, and the second term is 8 epsilon dot k prime square p dot k minus 8 epsilon prime dot k square p dot k prime. So, T2 is nothing but the sum of these two terms. Therefore, I can simply add them to get T2. So, it is just 8 p dot k p dot k prime times twice epsilon dot epsilon prime square minus 1 plus 8 p dot k epsilon dot k prime square minus 8 p dot k prime epsilon prime dot k square. This is our T2. Now, I have to find T3 from here, but you can see that if you make this transformation epsilon goes to epsilon prime and k goes to minus k prime, then here it will pick two minus signs here because k goes to minus k prime goes to minus k. Therefore, this whole thing is invariant here, epsilon and epsilon prime are interchanged, there is a whole square. So, the first term is invariant, and under this exchange the second term goes to the third term because there is a minus p dot k prime here and this is epsilon prime dot k, and this term goes to this. So, the second and third term interchange and the first term remains invariant. Therefore, T2 is invariant under this transformation. But we have seen earlier that if we make this transformation in the original trace, then we get T3. This simply implies that T2 is equal to T3. All right. So, what we have done is we have just derived an expression for T1, T2, T3 and T4. We will put all these things together and then we will see what we get for x. So, let me write the answer for T1 and T2 also. T1 is equal to 8 p dot k twice epsilon prime dot k square plus p dot k prime, and hence T4 is equal to minus 8 p dot k prime twice epsilon dot k prime square minus p dot k. This is your T1, T2, T3, T4, and your x is 1/16 m square p dot k square T1 plus 1/16 m square p dot k prime T2 plus T3 and plus 1/16 m square p dot k prime square T4. Now, I will substitute for T1, T2, T3, T4, and then you will see that after a little bit of simplification, this quantity will reduce to this simple expression 1/2 m square k0 prime over k0 plus k0 over k0 prime plus 4 epsilon dot epsilon prime square minus 2. This is what we get for x, and d sigma is nothing but its alpha square over 2 into x into k0 prime over k0 whole square d omega. If you look at what we have discussed in the earlier of the lecture, therefore, this simply implies d sigma over d omega is equal to alpha square over 4 m square. I will simply substitute this for x here, then what I get is k0 prime over k0 square times k0 prime over k0 plus k0 over k0 prime plus 4 epsilon dot epsilon prime whole square minus 2. So, this is the expression for the differential scattering cross section that we got after doing the complicated calculation. I will briefly tell you if what we can do is that we can also average over the photon polarization. We can also assume that our initial photon is unpolarized, and we also do not detect the final photon polarization. Then all other terms are not affected except this one, because this involves the photon polarization. What I claim is that if you consider this, so you have half epsilon dot epsilon prime whole square sum over epsilons and epsilon prime, all possible values of epsilon and epsilon prime. This is half cos square theta, where theta is simply equal to theta, cos theta is k dot k prime divided by mod k prime. It is angle between the initial and the final photon. You can show this, and you can substitute it in the expression for the differential scattering cross section, and find the scattering cross section when the electron as well as the photon are unpolarized. All right.